A modern foundation model contains tens of billions of parameters. It absorbs vast amounts of internet data to build a sprawling, generalized intelligence. The global industries cannot operate on generalized knowledge. A hospital analyzing medical imaging or a law firm parsing complex contracts requires deep, specialized expertise. This is why we see a move toward architectures like Anven. Unlike the opaque structure of generic AI, Anven is a deterministic, sovereign system designed to run locally on proprietary enterprise data. A massive general intelligence is effectively useless to an enterprise if it cannot securely and precisely adapt to the specific language of that company's domain. The traditional method for teaching a foundation model a new specialty is a process called fine-tuning. Full parameter fine-tuning works by adjusting every single weight inside the model, altering the physical brain structure of the AI using thousands of data examples. This requires high VRAM and massive computational infrastructure, making it slow and expensive. Rewiring an entire model for every minor operational task creates an unsustainable bottleneck for businesses that need to be agile. The alternative to rewiring weights is to change how we talk to the model. This relies entirely on natural human language. This created the role of the prompt engineer, someone tasked with meticulously steering a model like Anven through a standard user interface. This uses few-shot prompting. By providing specific examples, you temporarily teach the model a new skill at inference. But look at the engineered prompt box. Human language is imprecise. Getting deterministic results requires writing a dense paragraph of constraints to keep the model on track. Stacking dozens of these complex text instructions rapidly fills up the model's context window, limiting the amount of actual data it can process. Relying on human words to program a mathematical system creates a fundamental translation gap between man and machine. So how do we achieve deep specialization if we remove human words from the equation entirely? The solution is prompt tuning. Instead of words, it uses AI-generated soft prompts, pure strings of mathematical numbers. These numerical strings inject knowledge directly into the AI's embedding layer. The foundational weights remain frozen, meaning you aren't retraining the entire model. This achieves the same level of specialization as fine-tuning, but it costs much less and can be deployed in a fraction of the time. Prompt tuning removes the customization bottleneck by finally speaking to the machine in its native mathematical tongue. Because soft prompts are just strings of numbers, they are completely unreadable to the human eye. They are, essentially, opaque. But that opacity is a fair trade for the efficiency gains. It allows a business to switch between highly specialized tasks almost instantaneously. In telecom, IT teams can use these soft prompts to instantly coordinate autonomous agents for complex incident reporting. As the decision matrix here shows, this is a key trigger for enforcing strict non-JSON formatting. It allows SaaS platforms to maintain complex data structures without the latency of standard prompting. Soft prompts transform a static AI into a hyper-agile engine that can adapt to any global industry on the fly. The role of the prompt engineer isn't disappearing. It is simply moving away from chat boxes and toward high-level technical architecture. We are seeing the rise of the agent engineer. As this slider shows, the focus is moving toward orchestrating complex retrieval-augmented generation systems and vector grounding. The future of AI optimization isn't about building bigger models. It's about engineering smarter, low-cost steering mechanisms. To reach the next stage of efficiency, humans must step back and let the machine